Hi everyone. In this lesson, we're going to go over how to construct confidence intervals for population proportion problems. Now, when you're faced with a problem that has a term percent or proportion in it, that's an indication that you are dealing with a population proportion problem. Now keep in mind the words percent and proportion are synonymous because the percent is equal to your proportion times 100. For example, if I say 1 in 10 people are left-handed, that gives you the proportion 0.1. And if you multiply that by 100, you get that 10% of the people are left-handed. So for these problems, you're looking for the term percent or proportion. That indicates that you're going to be dealing with a population proportion problem. Now here are some examples of typical population proportion problems. For example, the Career Services Director at Southern Technical Institute would like to know the percent of graduates entering the job market in a position related to their field. So you see the term percent. A company representative would like to know the proportion of Burger King sales that are made at the drive-through window. So you see the term proportion. An air conditioning company would like to know the percent of new home constructions that have central air conditioning. A baseball glove manufacturer would like to know the proportion of left-handed people in the population. So all of these problems are examples of population proportion problems. So now let's discuss how to construct a confidence interval for a population proportion problem. So to construct a confidence interval for a population proportion problem, this is the formula down here that we're going to use. For example, consider this question. What proportion of Wilson High School students are left-handed? So, to answer this question, you would want to construct a confidence interval. So you take a sampling, say it's of size n students, and suppose that you find x of them are left-handed. Then your point estimate for the population proportion of left-handed students would be this right here. Notice we use the notation p hat, so that's going to be x divided by n. That is your sample proportion right here. And from this number, you construct this confidence interval that we have listed here. So you take p hat plus and minus z alpha over 2 times the square root of p hat times 1 minus p hat divided by n. That's the formula that you use, where the z alpha over 2 is, as we constructed before, your cutoff corresponding to a significance level of alpha that you want for your confidence interval. Now, we're going to justify this formula later on, but right now we're just going to work with it. This is the formula that you use. Also notice now for population proportion problems, we're back to using z again. We don't use the student t distribution, we use the standard normal distribution to construct our cutoffs z alpha over 2. Now let's take a look at this example illustrating how to construct a confidence interval for a population proportion problem. Now in this example, the union representing the Bottle Blowers of America, BBA, is considering a proposal to merge with the Teamsters Union. According to BBA union bylaws, at least 3/4 of the union membership must approve any merger. So a random sample of 2,000 current BBA members is taken and reveals that 1,600 out of the 2,000 plan to vote for the proposed merger. Now we have these questions to answer. Part A, what is the point estimate for the proportion of members who support the merger? Part B, develop a 95% confidence interval for the proportion of members who support the merger. And then Part C, based on the sample information, can you conclude that the proposed merger will pass a full vote, and why? So for Part A, our point estimate is merely going to be 1600 divided by 2000. That's going to be our point estimate. You see, the 2000 is the n, and the 1600 is the x, the number of successes out of 2000 trials. Now when we evaluate this, we get 0.8. That is our point estimate for the proportion of members who support the merger. Now for Part B, we want to develop a 95% confidence interval. Now in this case, note that our significance level is 0.05, 1 minus 0.95. Our z alpha over 2 value will then be 1.96. You can get that from the table, or you can use the norm.inverse function in Excel, recall. So we need to use this formula, p hat plus and minus z alpha over 2 times the square root of p hat times 1 minus p hat over n, where p hat is our point estimate. So plugging all of our information in to this formula right here, we get 0.8, that's p hat, plus and minus 1.96, that's z alpha over 2, times the square root of 0.8 times 1 minus 0.8 divided by 2000, and if you evaluate both of these numbers with the plus and minus, you get this as your interval. So here is our 95% confidence interval. And recall, that means that we have a 0.95 probability that the true population proportion is between these two numbers. So that's our 95% confidence interval. Now Part C, what can we conclude about the likelihood that the merger will pass a full vote? Well, notice that we need 75% or more of the members to approve the merger, and notice that 0.75 is to the left of this interval. So, if we put this on a number line here, here's 0.75, and our confidence interval is over here. This is 0.782, and this would be 0.818. And our point estimate is right in the middle here. So notice that since 0.75 is smaller than the left-hand endpoint of our confidence interval, it does appear that this merger will pass a full vote.